MongoDB. I wrote a short blog article comparing MongoDB and Firebase from my own experiences on a specific project, Course Pilot. I'll link it below, but the long and short of it is I definitely prefer MongoDB. I think when first using a database, it can be a bit overwhelming. I certainly felt that way. At first, it felt like I was coding whilst blindfolded, but after a few projects, I was like, oh, this is actually surprisingly easy. A lot easier than some of the front-end stuff. So let's dive into it. The MongoDB database platform is called Atlas. The first step is to sign up or log into your account. Then you'll come to your dashboard. Let's build a database. Select free tier or not. If you're also welcome to use other tiers. I'm going to choose free tier. Choose your closest region. Mine is Ireland. You can give your database or cluster in Mongo speak a name if you want to. I'm not going to bother here. I'm just going to keep it as cluster 0. Cool. Whilst my database is getting set up, we can choose how authentication is going to work. This is for security purposes. Only database users can access databases hosted on Atlas. I'm going to go for username and password. And for username, I usually just give it the project name or some super brief project description. And I'll get the password auto-generated by Atlas. You can input a password yourself as well, whichever works for you. Just remember to take a note of whatever password you choose. We'll need it later. If we scroll down, we want to add our current IP address to our IP access list. That's it. That's the setup on the MongoDB end. We just click on this add current IP address here so the orange warning banner can disappear. Let's connect our database to our project. There are 4 different ways. The easiest for me is to connect via node.js driver. MongoDB documentation can be a bit of a maze sometimes. Some are much more helpful than others, and the connecting to your cluster documentation is really good. So if you want to explore some of the other methods to see which one works better for you, I'll link the URL below. With the node.js driver, we just need to copy and paste the string provided to us in a .env file in our backend. We are currently in our project's backend folder here. If you don't know how to set up the backend, here's a flashback. In our backend, I'm calling this .env file .env.dev, and the name of the MongoDB string, I'll call it db_URI. The standard is to have all capital letters with words separated by an underscore. DB is short for database, and URI is short for Uniform Resource Identifier, not a typo of URL. You see why we need to note down that auto-generated password? We need to replace this reference to password here with our actual password. You can also see the reference to cluster 0. So if you did choose to give your cluster a different name, after the @ sign here, it'll be that name. And whilst in the .env.dev file, I'm going to establish the backend host and port number as well. You'll see this being used in a bit. The front-end port will usually be 3000, so for the backend, the process will be a lot smoother if you give it a port number that's different to 3000. I flip between 4000 and 3001, depending on my mood. You can choose a number that you prefer. The foundational packages that we'll need for our backend in our index.js file will be body parser, course, .env, Mongoose, and express. I forgot express here. I'll add it later, but to save you from having to go through an error, you can import express from express whilst you're here. Mongoose is a schema solution to model our data. What that means is by having a schema, it defines how our data is structured. If we enter data that doesn't match up to the schema, so for example, if we said a user's phone number will be a number, then we try to pass an array into the database, we'll encounter issues and errors. Think of it as a very, very good goalkeeper. Having a schema is definitely the best practice. If you don't have a schema, you can still save data to your database, but you'll be prone to errors down the line. Then we just go through the process of setting up the backend. We're using Express, which is a super popular Node.js framework that helps us to manage servers and routes. You'll see how simple it is. To set it up, it's const app equals express. Mongoose.set strict query true is telling Mongoose that only the fields that are specified in our schema will be saved to the database. If some other fields are sent, it will not be saved. Mongoose version 7 onwards will be set to false by default. I like to set it to true because from my point of view, the whole point of having a schema is because I only want the data specified in the schema to be saved in the way that it should be. So if I accidentally pass something else through and we just accept it and save it, then to me, that defeats the purpose of having a schema. Of course, different use cases, different rules, and you can assess which is the most appropriate for your project. And then we have app.use. .use is an express method, and it's to set up middleware for our application. If you've not heard of middleware as a terminology before, it's generally defined as a layer of software that enables interaction and transmission of information between applications and services that make up a complex system, providing a uniform user experience. So it's the methods or functions or operations that are called between processing the request and sending the response in your application method. It's like a middleman, like an estate agent if you're renting a flat. And we need express.url encoded, which is a method inbuilt in Express to recognize the incoming request object as strings or arrays. We need course. Course, as a terminology, stands for cross-origin resource sharing. It supports secure cross-origin requests and data transfers between browsers and servers. I'll link the MDN explanation of course below. Course is also a Node.js package for providing an Express middleware that can be used to enable cross-origin resource sharing with various options. If we don't have this enabled, we will definitely get a cross-origin error. And our host will be the host that we wrote out in our .env file, and it's the same for port. If you're just practicing, it doesn't need to be this convoluted. You can just write down the string here. But if you're thinking of deploying the backend to render or something, keep in mind that your host will change, and it's always safer to keep your host address a secret, hence the .env file. Now, connecting to our database. We use an async function. I like to console log that it's connecting first. Then we can do a try-catch block. We will try to connect to our database using mongoose.connect, passing in our DB URI. If it works, we log an affirmative message. We will catch and log any errors. Then we just need to apply this function, like that. We also need to start the server. So we do app.listen, which is an express method, and we tell it what to listen out for. Here we're telling our application to listen on localhost and port 4000 for connections. And just to make sure that we're listening to the correct host and port, we can log the server.address.address and server.address.port, which will tell us exactly what host and what port we're using. Now let's set up our Mongoose schema. Mongoose is pretty old school, and you can tell from the documentation layout. I know there's a buzz with Prisma at the moment. I haven't tried it yet, but I will give it a go at some point, and we'll see it being used in future projects or not. So the first schema we're going to create will be an events schema. The application is an event sharing application, right? So one set of data that we will want to collect is everything related to the event that we're going to display on our front end. This is called a collection of data. So we import Mongoose from Mongoose. Our events schema will be a new Mongoose schema. And it'll have a list of things that we'll need, like the organizer's name, the event description, the date, start time, end time, price, link, location, etc. The most common types are string, number, array, boolean. There are also a number of others that you can use. I'll link the list of Mongoose schema types down below. And finally, we establish our model. So const events model equals new Mongoose model. The first argument here is the name of our model. I'll call it event. The quirk here is that it must be the singular name of our collection, not plural, and usually capitalized first letter. Then we pass in our schema. The mongoose.model function makes a copy of our schema and compiles the model for us. Then we just export default events model. And that's our events schema and model done. Now let's see how data is entered into our database in our backend. We have a roots folder, and in our roots folder, let's have events.js. In our events root, we'll need express and our model. We set up and export the root by using express.router. This is telling Express to create a new router object. Then we establish an instance of a single root, so that's eventsrouter.root, with a /string in the parentheses. We'll be posting an event. The four most commonly used HTTP methods for RESTful services are post, get, put, and delete, right? We're setting out what happens after we've posted an event from our front end. So we use .post. It'll be an async callback function that listens to the incoming request object and responds accordingly using the res response object. Both rec and res are made available to us by the Express framework. We then establish the new event in our backend here by setting up a new events model, passing in the body of our request. This request model will come from our front end, which you'll see later. Then we try to save the data using the .save method from Mongoose. If that's successful, we send a 201 status as a response, and then the express method .json, which passes incoming requests with JSON payloads. An alternative is the express.send method, which sends the HTTP response. In terms of what numbers to use as a response status, I'll add a link in the description. Have a look. There are a few funny ones. Leave a comment below on the ones that you enjoy the most. My favorite is status 418. I'm a teapot. It was a April Fool's joke, but they've kept it, so I love it. And of course, we catch any errors here in our catch block. If there is an error, we can send a status 422 and an error message. To direct us to this events route, in our index.js in our backend, we import the events router, then do app.use, give it a sensible route name, and tell it that it's the events router. The quirk here is that when we're importing events router, we need to add .js at the end here. Alright, now let's handle the front end part. How do we pass this request.body data to our backend? We go into our add-event-form.jsx component in our front end. In our handle submit function, we have e.preventDefault. We should do some light error checking to make sure that the user is not submitting empty fields. I'll come back to this later, so I'm just going to leave a note here as a reminder. It's nothing complicated, just long and time-consuming. If we have all of the data from the relevant input fields, we can start organizing our data into an object in the same structure as our schema. It's a fairly long list, so I've copied the schema into a comment here so I can make sure that I'm not missing anything. For the organization name, I'm going to hard code it for now. We can eventually get it from our user authentication process. We don't need the user to type it in again. The rest should be straightforward. Note that we have said in our schema that location will be an object. We need to reflect that here. Once we have the neat object, we can do a try-catch block. At this point, let's install Axios. You can use the fetch method as an alternative as well, but given that this project will be passing a lot of data to and from our backend, Axios is just that much easier. Once installed, we import Axios, and in our try block, we do const res equals await axios.post. Because this is an async function, we need to go up and add async here. Let's write out our backend root in our .env file. Remember to add React app at the front like this. It's a React quirk. Then we need to add our backend events root as the first argument of axios.post method. The second argument will be our events object that we've just done. If res.status is equal to 201, we can navigate back to our homepage. Navigate will use the useNavigate hook, which is a React router DOM hook. So we need to import it and add it to the top like this. If we quickly try it, a step I'm missing out here is testing our backend with Postman. I am so bad with using Postman. I kind of just brutally console log my way through testing. It's not the best practice, but sometimes I just get frustrated with how long it takes to test with Postman. And if it doesn't work, it doesn't necessarily tell me anything more than that it's not working, which I can also tell by doing this. And at this point, usually I do get it to work the first time round, so I skip Postman a lot. These are all just excuses. It's bad practice. You should definitely try to integrate Postman into your workflow. But anyway, we've been taken back to our homepage, so I'm at least 80% sure that we've done everything properly and that we've got our data. But we can pull up MongoDB Compass and see. If you're using Compass, you need to download it from MongoDB. If you don't want to use it, you can just go back to the MongoDB website and log in. You can access the same data. I just find Compass easier and the display is ever so slightly better. And we can see we've got it. Great. That was just how to post an event. Now, how do we get our event from the backend and display it on our front end? Back in our backend, in our events root, so that's our events.js file, we need to set up a GET request. That's .get and then an async callback function. Try catch block. In our try block, in order to get all events, we just need to do const events equals await events model.find and an empty object in our Mongoose find method. We talked about res.send method just a minute ago, right? As an alternative to the JSON method. So we're using that here. We can send the events back to our front end by doing res.send and events in the parentheses. Any error we catch, we console log it. Then in our front end, we'll use React useState hook to remember our data. So const events set events equals useState. And it will be an array, so the initial state is an empty array. Then we can work on the getEvents function. It will be an async function, and again, try catch block. Const res equals await axios.get. Then our backend root here. We then set events as res.data. Catch and console log any errors. We want to get the events every time the web app runs, so we use the useEffect hook. And get events here. Now if we console log events, here we go. That's the event we just posted. We can now display it however we want, wherever we want. This is a very simple demonstration of how to get data from and post data to our MongoDB database. There are a whole bunch of other useful Mongoose methods that you'll use over and over and over again, like find one, find and update, update one, remove one, etc. If you explore the backend GitHub repo, you'll see how it's done with the user authentication process. So logging in, signing up, forgotten password, reset password. So check out those backend routes to see how the various Mongoose methods are used there. The flow is more or less the same, so it shouldn't be difficult to understand. But let me know if otherwise. The next video will be how I converted this into a Next.js project, because Next.js is lightning fast and it's just so much easier to deploy to Vercel that way. And then after that video, I'm not sure what to do next. I'm thinking either a MERN link shortener or a chat room, or just jump straight into Next.js. I'll have a think. You let me know what you'd prefer as well. See you next time.